Welcome, my dear learners, to today's episode on the very channel. In today's lesson, we shall be looking at the application of the laws and properties of logarithms in solving questions. So here are a few examples that will be looking at them one after the other. So we are to evaluate, meaning we want to find the value of each of these logarithmic expressions. So let's start with this one. We want to evaluate 1/2 multiplying log of 81 to the base of 3. We want to find the value of that. Now we know that 81 can be written as 3 raised to the power 4. 3 raised to the power 4 will give us 81. So in place of 81, we are going to write 3 raised to the power 4. So you have now looking at this, we are having log of 3 raised to the power 4 to the base of 3. Applying this law, we can write this as that. So it means that the power will come in front to multiply the log. So with this, the power will come in front to multiply the log. So you have this power will come in front. We have 4 multiplying 1/2 log of 3 to the base of 3. So you can see that this 2 can cancel 4. We have 2. We have 2 multiplying log of 3 to the base of 3. Now applying this property, we see that the logarithm of a number to the base of the same number gives us 1. Therefore, this is going to give us what? 1. So we have 2 times 1 and then we have 2. So the value for this logarithm expression is 2, as easy as that. We want to look at another approach to this very question. Looking at this very law, we said that when you have the power or n multiplying the log of s to the base of n, we can write it as this. The power will come and raise the number. So looking at this number multiplying the log will come to this side. So you will have log of 81 raised to the power of 1/2 all to the base of 3. Applying this law. So we have log of, now this 81 can be written as 9 raised to the power 2 because 9 raised to the power 2 will give us 81. So you have 9 raised to the power 2 or raised to the power 1/2 to the base of 3. Applying the power law of indices, this is going to give us 9 raised to the power 2 times 1/2. This will cancel this, we are left with 9. So we have log of 9 to the base of 3. Now looking at this, we can write this as 3 raised to the power 2. So in place of 9, we are going to write 3 raised to the power 2. So we have log of 3 raised to the power 2 to the base of 3. Applying this same law, we can write this as 2 log of 3 to the base of 3. And applying this property, this is going to give us 1. So at the end, you have 2 times 1. That gives us 2, as easy as that. So you can apply any of these approach. You are going to get the same results. So let's look at our next example. We want to find the value for this logarithm expression. So we have 4/9. We know that 4/9 can be written as 2/3 all raised to the power 2. Because when you expand, we are getting 4, we are getting 9. So in place of 4/9, we are going to substitute 2/3 all raised to the power 2. to the base of what? 2 over 3. Applying this particular law, we are going to write this as this power will come in front, so it will come and then multiply log of 2 over 3 to the base of what? 2 over 3. Now, applying this property, when you have logarithm of a number to the base of the same number, we are having 1. So this will give us 1, and we have 2 times 1, that gives us 2, as easy as A, B, C, D. Now with this same question, let's look at another approach. We can decide to equate this to any variable at all, let's say x. Now you can write this in an exponential form, where the base of the logarithm will come and be the base of the index. So you have 2 over 3 raised to the power x is equal to 4 over 9. Now let's express this in the form of 2 over 3 all raised to the power 2 is equal to 2 over 3 raised to the power x. Since the bases are the same exponential equation, what do? We equate their exponent. So we have our s is equal to that. As easy as A, B, C, D. Let's look at our next one. So let's look at our third example. We want to evaluate this logarithmic expression. Now looking at this is the same as this, so we are going to apply this particular law, which says that when you have log of x to the base of a plus log of y to the base of a, which is the same as this, it is equal to log of x multiplying y to the base of a. So we are just going to take one of the log to the base of 5. So we have log to the base of 5, and then we multiply all the numbers. So we have 12 times what? 10. So this gives us log to the base of 5, and this gives us 120. You want to evaluate, you want to find the value of this, not simplify. So this is a simplified form of this, but I want to find the value of that. So this can be explained as, to what power must 5 be raised to produce 120? So you can write it mathematically as, to what power must 5 be raised to produce 120? Another approach is, you can equate this to any variable at all, let's say x, and then you convert this to an exponential equation, so that the base of the logarithm will come and be the base of the index. So we have 5 raised to the power x is equal to 120. Now looking at this, we are having an exponential equation, but the bases are not the same, and we can't express 120 to the base of 5. So what we do is, we take the logarithm on both sides of the equation, and the logarithm must be to the base of 10. So we have log to the base of 10, and then we have 5 raised to the power x. We have log to the base of 10, we have 120. Now applying this law, very important law, this can be written as that, so the x will come and multiply the log. So we have x multiplying log of 5 to the base of 10 is equal to log of 120 to the base of 10. We want to find the value for x, so let's divide both sides by log of 5 to the base of 10. So this and that will cancel, we are left with x. Now when you punch log of 120 to the base of 10 divided by log of 5 to the base of 10 on your calculator, you have 2.975. So this is the value for this particular logarithm expression. Let's look at another set of questions. So we have our next question. We want to evaluate this logarithmic expression. In other words, we want to find the value for this. Now with this question, we are going to apply two of the laws of logarithm simultaneously. We are having a plus and a minus here. So the plus is for this law, and then the minus is for this law. And we observe that the basis of the logarithms are all the same. So we can write this as log to the base of 4, and then when they are adding, we multiply. So we have 9 times what? 21. When they are subtracting, we divide. So divided by 7. Now that we have this, let's break it down small. We know that 7 can cancel 21. We have 3. 9 times 3 will give us 27. So we have log of 27 to the base of 4. Now, once we have this can be explained as to what power must 4 be raised to produce 27. So we can write it in a mathematical form as 4 raised to what power will give us what? 27. Another approach, you can equate this to any variable at all, let's say x. Then the base of the logarithm will become the base of the index, which is x. So we have 4 raised to the power x is equal to 27. Now, once you have this, you realize that the bases on either side of the equal sign are not the same, so we can't equate their exponents. So what we do instead is to take the logarithm to the base of 10 on either side of the equal sign. So you have log to the base of 10 of 4 raised to the power x is equal to log to the base of 10 of what? 27. Applying this law, a very important law, we can write this as that. So the x will come in front to multiply the log. So you have x multiplying log of 4 to the base of 10 is equal to log to the base of 10, and then we have our 27. So let's continue from this side. Now we are interested in finding the value for x. So let's divide both sides by log of 4 to the base of 10. Now when you point this on your calculator, you are going to get 2.3774, and that is the value for this logarithmic expression. Let's look at our last example. So we have our last example. We want to evaluate log of 16 multiplying log of 27 divided by log of 9 multiplying log of 64. As I said in our previous lesson, when the base of the logarithm is not written, we assume that that logarithm is in base 10. So all these logs are in base 10. Now we know that 16 can be written as what? 2 raised to the power 4. Or we can write 16 as 4 raised to the power 2. So in place of 16, we are going to have 4 raised to the power 2. So you have log of 4 raised to the power 2, and then this means multiplication. And then we can write this as log of 3 to the power 3, because 3 raised to the power 3 will give us 27. Now all of this divided by, we can also write this as log of 3 raised to the power 2 multiplying log of 4 raised to the power 3, because 4 raised to the power 3 will give us 64. Now looking at this, we have log of 4 raised to the power 2. Applying this law, the power will come in front and then come and multiply the log. So this will come in front. You have 2 and then multiply log of 4. And then we have this 3 also come in front. We have 3 multiplying log of 3 all over. This, the 2 also come in front. We have 2 multiplying log of 3. And then we have this 3 also come in front. We have 3 multiplying log of 4. Let's do some rearrangement here. Since these two numbers are multiplying and multiplication is commutative, the positioning will not affect the expression. So we can write this as 2 log of 4 multiplying 3 log of 3 all over. Let's bring 3 log of 4 in front. So we have 3 log of 4 multiplying 2 log of 3. So from here you can see that log of 4 cancel log of 4 because they are all multiplying and then they are dividing. Log of 3 will cancel log of 3. We are left with 2 times 3 will give us 6. 3 times 2 will give us 6. This will cancel this. We have our final answer 2p1. And this is the value for this logarithmic expression. This brings us to the end of today's lesson. I'll be giving you a tutorial set question. Write them down, you try your hands on it. So this is your tutorial set. See you tomorrow. Bye bye.